Hello students, this is the first session of the chapter Biochemical Techniques which details about different chromatographic techniques. Chromatography is a modern technique for the separation, isolation and identification of the constituents of a mixture. From a mixture of different components, we can separate, isolate, and identify each component using chromatographic techniques. It is based on the general principle of distributing the compounds of a mixture of organic compounds between the two phases by name a stationary phase and a mobile phase. A stationary phase can be a solid or a liquid spread on a solid, while on the mobile phase, which is a liquid or gas. This can be also defined as a technique for the separation of a mixture by passing it in solution or suspension through a medium in which the components move at different rates. Based on the nature of stationary phase and mobile phase, there are different type of chromatographies, which are adsorption chromatography, partition chromatography, gas chromatography, and paper chromatography. Coming to paper chromatography, it is a special case of partition chromatography in which a paper strip acts as adsorbent column. Here, the paper strip is acting as the adsorbent column, and here, stationary phase and mobile phase both are liquids. Stationary in the form of a liquid is held in the pores of filter paper called Watsman filter paper, and this is useful for the separating complex mixture of compounds having similar polarity, for example, amino acids. The setup has three components. The paper chromatography setup has three components. The mobile phase is a solution which travels up the stationary phase due to capillary action. The mobile phase is generally an alcohol solvent mixture, while the stationary phase is a strip of chromatography paper, also called chromatogram. A chromatographic method is called adsorption chromatography if the stationary phase is a solid. This picture illustrates the process of paper chromatography. There is an important term in chromatography called RF values, based on which for each component the RF value will be different. It will be characteristic of a component. Based on the RF value, comparing with the non-RF values, we can identify the compound. It can be defined as the ratio of distance traveled by the compound and distance traveled by the solvent. The distance traveled relative to the solvent is called as RF value, that is retention factor. RF value means retention factor. For each compound, it is specific and can be worked out using the formula RF value is equal to distance traveled by the compound divided by distance traveled by the solvent. There are many applications for this paper chromatography. That is, among all chromatographic method, paper chromatography is an inexpensive, it is cheap and rapid method that provides graphic and clear results. It is used as qualitative method for identifying the components in a mixture. The separated spots on the finished and dried chromatogram can be cut out and redissolved to obtain a pure sample of component of the sample mixtures. The technology is used in several scientific studies in identification of unknown organic and inorganic compounds from the mixture. In forensic studies also, paper chromatography is used in crime scene investigation and DNA and RNA sequencing along with other studies, and it is used as an analytical chemistry technique for identifying and separating colored mixtures like pigments, sugars, amino acids, lipids, nucleic acid, and other biomolecules can be easily identified by spraying with appropriate reagent to detect these specific compounds. It can be reproduced easily as long as the conditions are controlled and maintained. These are a few applications of paper chromatography. Coming to another type of chromatography called thin layer chromatography or TLC. It is a special type of adsorption chromatography in which a glass strip coated with a thin layer of the adsorbent act as a stationary phase. Normally, this thin layer of adsorbent will be made up of silica gel. So using that, a thin layer will be coated on the glass plate and that will be dipped in a beaker containing the solvent. It is a chromatographic technique used to separate non-volatile mixtures. Thin layer chromatography is performed on a glass sheet, plastic or aluminium foil, which is coated with a thin layer of adsorbent material, usually silica gel or aluminium oxide or cellulose. This layer of adsorbent is known as stationary phase. Here you can see in this picture, this is the beaker which contain the solvent. It can be any solvent in which the compounds are soluble. So here this compound will be taken and here what will happen is this glass plate is coated with a thin layer of silica gel and there is a spot of the component mixture. Here we put one spot and through this adsorbent, when the solvent is raising through capillary action, along with that different component is having different RF values. Depending on the RF values of the component, there will be differences between the height of the compound where it has reached once the alcohol or the solvent is raising through the capillary. From the RF value of each component, we can identify which are the component and we can separate and we can identify the components in a mixture. Here you can see there is a spot together which is a components mixture and after some time when the through the capillary tube through the silica gel when the solvent is raising slowly the components of the mixture start separating and after some time there is quite remarkable differences between the spots and from once it is reached to the maximum then we take out the plate and calculate the RF values of the sample. Through that, we can identify and separate the components using thin layer chromatography. After the experiment, the spots are visualized simply by projecting ultraviolet onto the sheet. The sheets are treated with a phosphor and dark spot appear on the sheet where compound absorb the light impinging on a certain area. Chemical processes can also be used to visualize spots. To quantify the results, the distance traveled by the substance being considered is divided by the total distance traveled by the mobile phase. This ratio is termed as retention factor. Coming to the application of thin layer chromatography, purity of sample can be carried out with TLC. Direct comparison is done between the sample and the standard or authentic sample. If any impurity is detected, and then it shows extra spots and this can be detected easily. Thin layer chromatography can be employed in purification, isolation, and identification of natural products like volatile oil or essential oil, terpenes, alkaloids, steroids, etc. Reaction mixture can be examined by thin layer chromatography to access whether the reaction is complete or not. This method is also used in checking other special processes and purification processes like distillation, molecular distillation, etc. Biochemical analysis also TLC is extremely useful in isolation or separation of this Metabolites are constituent from its body fluids, blood plasma, serum, urine, etc. TLC methodology is increasingly used in chemistry for the separation and identification of compounds which are closely related to each other. It is also used for the identification of cations and anions in inorganic chemistry. Various pharmacopoeias have adopted TLC technique for detection of impurity in a pharmacopoeial chemical. Various medicines like hypnotic sedatives, anticonvulsant tranquilizers, analgesics, local anesthetics, etc., have been tested quantitatively and qualitatively by TLC method. One of the most important applications of TLC is in separation of multi-component pharmaceutical formulation. In food and cosmetic industry, TLC method is used for separation and identification of colors, preservatives, sweetening agent, and various cosmetic products. So in this session, we have seen about the um, applications of paper chromatography as well as thin layer chromatography.